Be talking to us about scientists you've never heard of. Before we get going, we just want to go over a couple things first. For those of you watching on Zoom, closed captionings are available. All you have to do is click on that CC button at the bottom of your screen and then select Show Subtitles. For optimal viewing, we recommend a side-by-side mode, so you can access that by clicking on View or Speaker View at the top of your screen, and then selecting the side-by-side mode. That's going to allow you to see both our presenters and their slides at the same time. And we want you to be active in the chat, so please drop all your questions and comments in there. But of course, we're going to ask you to be good digital scientists and citizens, So keep it relevant to the event and make sure things are positive. And to get that chat going, we want to know, what is your favorite unheard of scientist? So maybe a researcher or scientist that not a lot of people know of, but should get more credit and respect than what they have in the past. So drop your answers in the chat, and we're going to hear all about some of the favorite scientists from Skelly and Adam here today. Scientists that hopefully you've never heard of. So without further ado, I'm going to turn it over to Skelly Hunt, and he's going to tell us all about scientists you've never heard of.
Thank you, Greg. Yes, we're really excited to have this opportunity today. I saw some guesses in the chat. Rosalind Franklin, that's a really good one. That's one that we chose today. Our theme for SciTech Expo this week is actually diversity in STEM. So Adam and I wanted to we thought this would be a good opportunity to feature some of our favorite unheard of scientists. The first one I'd like to start out with is one of my personal favorites, Ada Lovelace. Ada was born in London, England over 200 years ago. So the year that Ada was born, Napoleon Bonaparte was defeated at the famous Battle of Waterloo. So that gives you a little context to see how long ago this was. Ada's father was hoping for a boy and left Ada and her mother a month after Ada was born. So she has kind of a tragic past. Her father was the poet Lord Byron, who you may have heard of. He was one of England's greatest poets. But Ada's mother hated Lord Byron, and because of that, she encouraged Ada to study logic and mathematics so that she wouldn't grow up a poet like her father. So Ada never met her father again, and she didn't even have a very close relationship with her mother. So she devoted a lot of her time in her childhood to studying. And at the age of 17, she became very interested in mathematics, and her connections with her family allowed her to study with some of the leading mathematicians of the time. When she was just 17, she developed an algorithm intended to be used for gambling at horse races, and her plan was to make a ton of money on horse races. Unfortunately, her first attempt at mathematics failed, and she ended up owing thousands of pounds to the gambling syndicate. So in 1840, she started working with the mathematician Charles Babbage. And they were working on writing an algorithm to compute a series of numbers called the Bernoulli numbers. And this algorithm was meant to run on his unbuilt analytical engine. And this algorithm is considered by many to be the first published computer program ever. And this was created as a computer program without a computer to run it. This picture here is of an analytical engine. It's one of the first prototypes built. This was actually built after Charles Babbage's lifetime because he was in constant feud with his engineers. So this program that Ada Lovelace wrote was actually never run until after Babbage's death. This computer was a fully mechanical computer, but it was also programmable and Turing complete. So moving a little later in time and across Europe to Austria, the next scientist I wanted to feature is Lise Meitner. So Lise originally studied and worked in Austria, and at the time, women were not allowed to enter higher education until the year 1897. So in 1897, she crammed 8 years of secondary education into 2 years, and she was able to enter the University of Vienna in 1901, right at the turn of the century. After she graduated from Vienna, she started researching optics And it was then that she was introduced to the pretty much brand new field of radioactivity. And her first experiments in radioactivity involving alpha particles eventually led to the discovery of the nuclear atom by Ernest Rutherford. So this is one of her most famous experiments. On the left hand of the slide, you see a big ball of blue and red particles, and that represents a radioactive substance such as radium. And radium releases alpha particles all the time as it decays, and that's that little offshoot there with 2 blue and 2 red, which is 2 protons and 2 neutrons. So she used radium, which emitted alpha particles, and then she used a device called the collimator, which is basically just a device used to narrow and focus a stream of particles, just like a hose on a faucet. And the alpha particles were then directed to strike a thin sheet of metal foil. In the example on this slide, gold is used. And when the alpha particles hit the gold, most of them pass right through, but a few of them are reflected. And this actually indicates that the positively charged alpha particles are striking something with a positive charge that causes them to bounce off. And because that angle is greater than 90 degrees, it indicates that the charge of the atom is not equally distributed. Instead, it's concentrated at the center. So this is the type of experiment that led scientists to understand that atoms have nucleuses where their positive charges are all concentrated in the center. I've got a couple photographs here which are interesting. They're really old and grainy, but if you look closely, you might be able to see Einstein on the front on the left, and then Lise Meitner on the right in the front, sitting right next to Otto Hahn, her scientific partner. So after her work with alpha radiation, Lise went to the Friedrich Wilhelm University in Berlin, and that's where she met Max Planck. And notably, Planck allowed her to attend his lectures and actually invited her to his home, which is interesting because Planck publicly opposed women being admitted to universities. So he apparently thought she was pretty special. It was at this university that she met Otto Hahn, who was her age, and he had actually already discovered several radioactive isotopes. He had been collaborating with physicists who were not men before, and so they hit it off immediately and started working together. At the time, Lise was not allowed to set foot in the laboratory, so she and Otto began doing unpaid research in a wood shop on the outskirts of the university. And the first year they worked there, whenever she wanted to use the toilet, she had to walk down to a restaurant down the street because she wasn't allowed in the building at the university. And the first 2 years they worked together, they managed to co-author 9 papers. They discovered isotopes, and they really furthered our understanding of how radiation worked in just a short period of time. So after 5 years, Otto was able to get his first salary as a professor, but the institute still wouldn't employ a woman. So Otto split his salary with Lise so that she could continue working with him. And the following year, they finally recognized her abilities, and they gave her a salary as well. Of course, it wasn't as much as Otto, even though she had the same title. Here's another good photograph of Lise. She's on the front row. She's one of only 2 women in the room, and you may recognize Niels Bohr and Werner Heisenberg, giants of physics, sitting right next to her. So Lise and Otto continued their research, and honestly, the number of discoveries that they made is too many to list here. It would take hours, but they include discovering countless isotopes of radioactive materials and really advancing our fundamental knowledge about nuclear physics. So moving on to 1938, Germany was unified with Austria, and Lise actually lost her Austrian citizenship. So she began looking for a position in Denmark or the Netherlands, but she was prevented from traveling abroad by the German government. So on the 11th of July, she came up with a plan with Otto. She went to work as normal with just her normal work supplies, a couple of books and papers, and then she stayed in the office late reviewing a publication for a colleague and used that as an excuse to spend the night at Otto's house, which was a lot closer to the university. And in the morning, they were walking and pretended to meet a friend by chance in front of the train station. So Lise posed as the wife of a professor, hopped on the train, and was able to cross the border safely. 6 years later, Otto, her partner, was awarded the Nobel Prize for the discovery of nuclear fission. The Nobel Prize committee actually excluded Lise despite this discovery being a joint venture of their laboratory. And Otto wanted to set the record straight, and so he later nominated her for the Nobel Prize multiple times. All right, moving on. Our next underrated scientist is Qian Shengwu. Qian was born in China, the middle of 3 children, and her father was a revolutionary fighter in China who formed a school for girls in their village. And her mother was a teacher at that school that was known to really value education for both genders, which was a little bit controversial at the time. So, of course, she received her elementary education from her father's school at the age of 10. And at the age of 10, she traveled 50 miles across the country to a boarding school. And admission for the teacher training at this school was highly competitive, but Qian applied, even though she could have paid her way in through her father's riches, but she applied and ranked really highly in applicants. She ranked 9th among 10,000 applicants, which is crazy. So at the age of 17, she graduated at the top of her class, and she went on to the National Central University and spent 2 years after that doing graduate level physics study. She decided with a friend that she wanted to move to America, so they both applied to the University of Michigan and were accepted. But when she arrived in Michigan, she found out that women were not allowed to use the front entrance, and she immediately left and decided to study at UC Berkeley. And it was while she was at Berkeley that she became interested in beta decay. You may remember we were talking earlier about alpha decay. This is just a similar type of radiation that Qian became interested in, and she would later explain beta decay entirely through her experiments. So after Berkeley, Qian became the first female member of the physics department at Princeton, and while she was at Princeton, she joined the Manhattan Project, where she was able to successfully diagnose a mysterious problem with the first nuclear reactor ever built. Reactor B was the first reactor built, and it was shutting down and starting up at regular intervals, and no one could figure it out. And so Enrico Fermi asked specifically for her help because of her work on beta decay. This is a schematic showing beta decay, and there's a picture of her talking with Enrico Fermi at the Manhattan Project. So after her work on the Manhattan Project, Wu continued to investigate beta decay, and she was eventually able to prove Fermi's theory of beta decay, which had been under debate among physicists for over 15 years. So this is an illustration of the Wu experiment, which is an experiment that she designed and executed in order to disprove the law of parity, which was considered by pretty much the entire physics world to be true. This is why it was called a law at the time. Things are not called a law without a lot of proof backing it up. And so obviously this experiment is extremely complicated looking at this diagram, but the results are fairly simple. In a world where the law of parity is true, a mirrored version of the world where left and right were swapped would behave exactly as a mirror image. However, if parity is false, as Qian Wu proved, then we're able to distinguish between a mirrored version of the world and our own. And the way she did that is by looking at the radiation coming off of a particle, the beta radiation. If it comes off equally in all directions, parity is true, but if it is asymmetrical in the radiation, it means parity is false, and we could tell the difference between 2 versions of the world mirrored. So her 2 partners in this project, Xingdao Li and Chen Yang, also received the Nobel Prize for this experiment. However, once again, Wu was excluded. So Li and Yang publicly stated that Wu had performed the main part of the project with her experiment, and they both jointly nominated her for the Nobel Prize after she was snubbed, the first of many more nominations for Qian. So at this point, I'd like to turn it over to Greg. If you have any questions from the chat about these scientists, I would be happy to try to answer them, or any of the science behind these experiments or what they studied. I may not be able to get into depth, but I'll certainly try.
Yeah, we have a question from the chat. Do you know if there's any program to formally recognize any of these scientists?
Yeah, so Qian Wu was actually received the Wolf Prize later on in life to make up for her snub for the Nobel Prize. And a lot of these scientists have been recognized by the scientific community afterwards, even though they never received the Nobel Prize.
Yeah, you said Lise Meitner had been nominated almost 50 times and never once received it.
That's right. Yeah, there was definitely some discrimination in the Nobel Prize committee at the time, and yeah, Chin Wu was also nominated many times. At some point in Chin's life, the Nobel Prize committee stopped publicizing their nominees, so it's possible that she had a lot more nominations than 7, like I listed, but they're just not public.
Yeah, we have a question from the chat. Do you think the situation has changed nowadays, or do we need to keep working on equality in the sciences?
I think there has been a lot of progress since then. However, I think equality is something we never can stop working for.
Yeah, certainly agree with you there.
Complacency is definitely not good in this respect.
Well, that looks like it. Skelly, thank you for highlighting these 3 important female scientists who have gone largely unrecognized until now. So thank you for sharing their stories.
Absolutely.
All right, let's go ahead and turn it over to Adam.
Go ahead and unmute myself. All right, so we're going to keep this adventure going and talk about 3 more scientists that either you may never heard of or whose achievements were maybe not recognized during the time as much as they should have been. We're going to get things started with a question. What do you all think that these technologies have in common? Here we have a pacemaker, a television, a computer, a guided missile, and a radio. Any ideas what these all have in common? I'll give you a hint. My first inventor of the day had a part in producing a piece of technology that made all of these technologies easier to make. Anything coming in the chat by any chance?
We see Marianne is guessing transistor. Hugo says radio frequency.
Okay, these are great guesses. So what I was looking for is actually they were all made possible by this patent by Otis Boykin. So the patent, the really groundbreaking patent, came in 1961 with Otis Boykin's electrical precision wire resistor. So it seems like it's not the most flashy invention, but it's super significant in the history of making these kinds of technologies much more available and much cheaper to produce, and therefore much more common in everyday households. So let's start talking about Otis Boykin's life. Otis Boykin was born in Dallas, Texas in 1920. He graduated as the valedictorian of his high school class and continued studying at Fisk University and graduated in 1942. Otis Boykin was African American, and so he attended Fisk University, which is a historically Black college and university. And at that time in the Jim Crow segregated South, he did not have the opportunity to attend a non-historically Black college or university. So he had to attend that school because white schools were not desegregated at that point. He pursued graduate studies at Illinois Institute of Technology and started in 1946, but he was forced to drop out because his family could no longer afford to pay his tuition. This did not stop our friend Otis Boykin. He worked as a consultant in Chicago, and this is where he was able to start tinkering with these electrical resistors, and where he ultimately developed the precision resistor that could resist an exact amount of current. So you could set it up so that it could be pre-programmed to resist an exact amount of current in the way that you wanted to. But the big achievement of his design is not necessarily the resistor, the precision of the resistor, but rather it was a really cheap and easy to produce model. This made electrical goods and electrical products much more available to average consumers, not only in the United States, but all across the world. It was also much more durable than other resistor models, so it was less likely to overheat or break. And while this sounds insignificant and a kind of small invention, this was absolutely radical and transformed a lot of different industries. Interestingly, one of the industries it transformed was the United States military. It was able to make guided missiles and other military technologies much cheaper and easier to produce. Otis Boykin continued to improve his resistors and worked on other inventions until ultimately passing away in 1982. My favorite of the other patents that he worked on before his passing was this really cool burglar-proof cash register that he was able to design and produce, which is a really cool kind of very different but somewhat related technology. So it's impossible to talk about Otis Boykin without talking about the history of segregation and prejudice in our country, because Otis Boykin suffered a lot of prejudice during his career, and that he was denied opportunities of education and denied certain career opportunities because of the color of his skin. So in 1942, Otis Boykin graduated from Fisk University, as I mentioned, at HBCU. That was 7 years before Jackie Robinson desegregated Major League Baseball. And then in 1955, you have really the start of the civil rights movement with the Montgomery bus boycott. In 1959, Boykin earned his first patent. And then after that, so that was before you had the March on Washington, the Civil Rights Act, and then the Voting Rights Act. So Boykin's inventions are coming at a really politically hot time. And in a time where his success and the relevance and importance of his invention really was incredibly helpful and productive in continuing this movement of desegregation and integration of all Americans into the sciences and into the limelight, which I think is super important. So if anyone has any questions now, I can answer some questions on Otis Boykin, or I can keep moving on to our next scientist.
Adam, I have a question. I'm wondering, I'm looking at your timeline here, and it says his first patent is in 1959. Do you think his race would it have made it more difficult for him to get patents that he, deserved?
Exactly. I absolutely think that it 100% would have. In fact, there's documentation that he kind of tried to apply for patents in the earlier 1950s, and he was denied at a couple of different places, and ultimately finally was able to get his first patent accepted in 1959. But it's really interesting to think, what if he had patents accepted years earlier? Unfortunately, he passed at a pretty early age in 1982. So it's hard to know what he would have been able to accomplish if he had been able to have an easier time getting his education, an easier time getting patents through into the mainstream. Yeah, and getting patents through. So that's a really good question. Anything else coming up? We can keep moving.
Let's see. Laura Beth is asking, was the patent used right away by other inventors?
Yes, I think his patent jumped off the shelf. I think it was immediately used by production companies, immediately used by the military. It was super popular right away. It was an incredible feat, even though it was a pretty small and not necessarily flashy invention. It was immediately used in production. So that's a really good question. All right, awesome. We'll keep it moving and talk about a scientist who's still living, in Mae Jemison. Some of you might have heard of Mae Jemison. I hadn't heard of Mae Jemison until I did research, and she is now probably my favorite scientist that I've ever researched. So Mae Jemison was born on October 17th in 1956 in Decatur, Alabama. My favorite Mae Jemison story actually came from elementary school. Mae Jemison came into school one day during career day. They asked all the students, what do you want to be when you grow up? And Mae Jemison told her teachers that she wanted to be an astronaut. Now, a lot of our teachers today, we're lucky to have teachers that are supportive of any dreams that we have. But Mae Jemison's teacher on this day, unfortunately, was not. Mae Jemison's teacher said, an astronaut? Are you sure? And then suggested some other careers like being a nurse, being a teacher, careers that at that time were more appropriate for females during that time period. Mae Jemison did not let that deter her. She ended up excelling in high school and then received acceptance in Stanford University and graduated in 1977 with a degree in chemical engineering and African American studies. After graduating from Stanford University, she attended Cornell University for medical school in 1981, and then she worked as a medical doctor for Peace Corps in Liberia and Sierra Leone. So she had a really interesting life and career before she even began working as an astronaut. But Mae Jemison never really forgot that conversation in elementary school, and she never let go of her dream. So in 1983, Sally Ride became the first woman to become an astronaut. And Mae Jemison said, if Sally Ride can do it, why can't I? Jemison decided to apply in 1985, but the applications were halted after the explosion of the Challenger in 1986, and hiring was suspended. But that didn't stop her from achieving that dream. She applied again in 1987 and was accepted. 2,000 people applied to become astronauts, and only 15 were accepted. And she made her first and only trip in 1992, and she was the first female African-American astronaut ever to go to outer space. So really incredible feat there. While in outer space, she worked as a doctor for the rest of the crew, but she also did a lot of really cool scientific experiments. She tested NASA's fluid therapy system and tested the production of saline in zero gravity. So she did some research onto the future of medicine in zero gravity, which I think is just the coolest thing. So Mae Jemison, her determination and her perseverance in her career, despite constantly being told, no, that's not for you, no, that's not for you, is really an inspiration to me, and I think just a really cool story. After 1992, she retired from NASA, and she opened her own organization that helped continue to pursue equality in sciences and in the social sector. So I think she has a really cool career where she was able to give back, but also do a lot of really cool scientific research. So if you have any questions for her, now would be an awesome time, but we can also get to those questions at the end if people are still thinking.
I'm not seeing any questions now, but I completely agree with you. She's one of my favorite scientists too. We actually have a painting of her in my daughter's room.
That's awesome.
Phenomenal, isn't she? A doctor and an astronaut. And
incredible.
All those
it's
other
crazy. I always joke with my family, these people, it's not fair. Like people who are this smart, I'm like, save something. You're a doctor, an astronaut, like save some for the rest of us. But
give me a little of that.
It's impossible to dislike her. She's such an amazing person, amazing scientist, and such a good person. All right, awesome. We'll keep it moving with our last doctor, or our last scientist. I did notice that this one came up in the chat, so someone else also has a lot of affinity for Rosalind Franklin. I think she's also one of the coolest scientists that I've ever researched. In Brenda Maddox's biography of Rosalind Franklin, she earned the nickname the Dark Lady of DNA. So I'm going to talk a little bit about Rosalind Franklin and why she earned that nickname. So Rosalind Franklin was born on July 25th, 1920 in London. She attended Newnham College at Cambridge University, and there she studied physical chemistry. During World War II, Rosalind Franklin started to dive into the research that would become so important to her helping discover the structure of DNA. So Rosalind Franklin studied the microstructure of coal and eventually earned a PhD studying this topic. After the war, Franklin stayed in a similar kind of field. She analyzed carbon molecules using X-ray crystallography. And then in 1950, Franklin went back to England and used these similar X-ray crystallography techniques to study DNA. So this is kind of where the controversy begins. And this story is super interesting and really controversial. So Rosalind Franklin came to England and started working at the John T. Randall's biophysics unit. Here, there was an assistant lab chief named Maurice Wilkins that had a huge part to play in her kind of a mission in the history of the discovery of DNA. So Maurice Wilkins had a dream to really work with, not a dream, but he had planned on working with Rosalind Franklin using this X-ray crystallography technique in order to take pictures and study DNA molecules. Rosalind Franklin there was some type of misunderstanding. Rosalind Franklin did not plan on working with Maurice Wilkins and rather wanted to work with Raymond Gosling, who was a graduate student and who she ultimately was continued to work with. Rosalind Franklin and Maurice Wilkins, their relationship never really healed from this initial misunderstanding, and they really had little to do with each other throughout her time at the John T. Randall's biophysics unit. So meanwhile, Franklin continued to work with Raymond Gosling and was able to get really clear X-ray images of DNA that had not been seen before. So this famous photo 51 on the right side of the screen is the famous picture, the clearest and most relevant picture that Rosalind Franklin was able to get of DNA. So unknown to Franklin, Wilkins went over to Watson and Crick, and you might recognize the name Watson and Crick because these two men are known as the fathers of DNA. They get a lot of the credit in history for discovering the structure of DNA. So Wilkins took this photo 51, essentially stole Franklin's research and showed it to Watson and Crick. And they looked at the image and it was absolutely essential to their description of the structure of DNA. Unfortunately, Rosalind Franklin passed away in 1958, but 4 years after that, Watson, Wilkins, and Crick shared the 1962 Nobel Prize for Physiology in Medicine, and Franklin received absolutely no recognition in this Nobel Prize award. So she was absolutely overlooked in this award, which is really, really terrible and really unfortunate, especially only 4 years after her passing. So what is the legacy of Rosalind Franklin and how is she remembered now? You have a picture of Watson and Crick over on the left, who are known as the fathers of DNA. Watson released a book in 1968, kind of an autobiography of his life and his research. And in the book, he mentioned Rosalind Franklin. In it, he mentioned that Rosalind Franklin, he mentioned a lot of sexist, kind of really negative terms regarding Rosalind Franklin, which are really untrue of her legacy and her career. He's called her Rosie, and he called her, he insulted her work and said that she got these images, but that she really would not have known what to do with them or not have known how to interpret them, which is not at all true. However, his book kind of backfired on him, and it, for the first time, really brought awareness to Rosalind Franklin's role in the development of, or the understanding of the structure of DNA. So for the next 10-ish years, a lot of people started kind of lifting Rosalind Franklin up as this figure for equality in science, and as this figure for incredible female scientists. And then Brenda Maddox wrote the biography of Rosalind Franklin that detailed more different parts of her life and her career. That's where she earned the nickname the Dark Lady of DNA. And in this biography as Rosalind Franklin, Brenda Maddox kind of pushes away from that description as kind of a martyr for female scientists and for women in science, because she thinks that Rosalind Franklin is a disservice to just think of her as a great female scientist, and that she's actually one of the most amazing scientists and scientific minds in the 20th century and in the history of scientific research. So she thinks that Rosalind Franklin should really be honored as a great scientist in general, rather than a great woman scientist. So I completely agree, and I think that she's one of the most interesting and incredible scientific minds. Rosalind Franklin's legacy did not end there. Her legacy still continues today. In Illinois, the Rosalind Franklin University of Medicine and Science is flourishing. It's one of the great medical schools in our country. And its mission, and you can see the logo inside of the university, is that famous photo 51. And Rosalind Franklin's legacy lives on and her spirit lives on, and their university is dedicated towards improving equality in medicine, physiology, and science, and also improving innovation in medicine and science. So I think Rosalind Franklin's career really left a huge mark on the face of science. And like Skelly mentioned, we obviously have a long way to go to improve equality, both among race and gender in science. And I think that these superheroes and super scientists are really huge, and that they were able to go up against the worst of it and kind of make it better. But we have definitely a part to play in improving equality in science as we move forward. With that being said, if there's any questions on anything that I presented on, or if you thought of a question for Skelly, feel free to ask either of us a question. But thank you so much for listening today.
Adam and Skelly, thank you so much for bringing these scientists to our attention. I completely agree with you. You know, they persevered during their time, and they never got the recognition that they truly deserved until more modern times. And just fascinating individuals. So thank you so much. I learned a lot. I hope the folks watching at home learned a lot about these scientists who have been unrecognized for just so long. If you want to learn more great, interesting things like this, we have a whole slate of presentations coming up during SciTech Expo. You can check out that schedule on our website. And I just learned that there's an escape room on there as well. So if you want to click around and try to get out of our genomics lab, click on the link in the chat and try your hand at our virtual escape room. So once again, we want to thank Adam and Skelly for their presentation today, but also a big shout out to our sponsors, the Biogen Foundation, NC SciFest as well. Without them, these presentations would not be possible. So big thanks to them, and thanks for everybody for watching. Y'all have a nice day.